Higher order differential equations. For a higher order differential equation, this is the form: function of d times y is equals to x power m, where x power m is an algebraic expression or a polynomial. We can first we will to solve this, first we will find yc by making the auxiliary equation as you learned earlier. For yp we have the form yp is equals to 1 upon function of d into the algebraic expression. So the function of d, we will convert the function of d into this form so that we can take the reciprocal and expand it binomially and then multiply it by the algebraic expression. So if this is the equation, this is the equation: d square plus 5d plus 4 times y is equals to 3 minus 2x. For yc, the function of d is equal to 0. So the function of d is d square plus 5d plus 4 is equals to 0. So we will find its roots by factorizing. The roots come out as d is equals to minus 1 and d is equals to minus 4. So yc becomes c1 exponential minus x plus c2 exponential minus 4x. Now for yp, the equation will become yp is equals to 1 upon function of d into function of x. So yp will become 1 upon d square plus 5d plus 4 into 3 minus 2x. Then we will convert the function of d into this form, which we will take the reciprocal and then we will expand using the binomial theorem. For a function like this, for an expansion of 1 plus x whole power minus 1, like in our case, the expansion will be 1 minus x plus x square minus x cube plus x power 4, where x is the second term and 1 is the first term. So yp will become, by expanding, 1 upon 4 into 1 minus d square upon 4 minus 5d upon 4 plus d power 4 upon 16 plus 25 d square upon 16 plus 10 d cube upon 16 and so on into 3 power minus 2x. Then we will now d here is equal to d upon dx, which is the differential. And if our equation, our polynomial has the higher order m and our differential has the order m plus 1, so the answer will be equal to 0. For example, if it is like this: d power cube into x square plus 2x, this means that it is d cube upon dx cube of x square plus 2x. This will be equal to 0. This means that for the highest order of the algebraic expression, if the differential is of an higher power, then the answer would be 0. So in this example, all the expression or algebraic expression is of the order 1. So all the differentials greater than order 1 would become multiply and become 0. So this whole thing, these will all become 0. And so this term will also be equal to 0. The remaining terms for d will be 1 minus 5 upon 4d. This is multiplying by 1 upon 4 and 3 minus 2x. So multiplying 3 minus 2x with this equation, it will become 3 minus 2x minus 5 upon 4 d upon dx into 3 minus 2x, where d upon dx is equal to capital D. So d upon dx means taking the derivative, first derivative. So taking the first derivative of 3 minus 2x, it would be minus 2. Then simplifying this equation, minus 2 and minus 4, this would result in this: yp is equal to 3 upon 4 minus half x plus 5 upon 8. So yp here will be 11 upon 8 minus half x. Therefore this is our yp. So the solution of this equation is y is equal to yc plus yp. Our yc is c1 exponential minus x plus c2 exponential minus 4x plus 11 upon 8 minus 1 upon 2x. So this will be the solution of our differential equation.